Okay, let's demonstrate payback, NPV, and IRR. Okay, IRR stands for internal rate of return, NPV stands for net present value. All right, let's assume we have a course of action or a project like this one. It will require $350,000 up front, and then we expect to generate these kind of cash flows after tax. Okay, this is all on an after-tax basis. Now, I don't know what the project is, it doesn't matter, but perhaps we can assume this is an HVAC system you're putting in the factory. So you're going to spend $350,000. Oh, by the way, this is in thousands. So you're going to spend 350 million, and you expect the new HVAC system in our factory will generate this kind of cost savings from lower utility costs. So that's a pretty good example we can work with. All right, so simple payback just means how long does it take before we get our money back? All right, so here's what I do. I compute a cumulative cash flow column, and then I just pull from the numbers to calculate that. So, I start off, period 0 means right now. So we're 350,000 out of pocket. At the end of year 1, take the 350 that you were out of pocket, the number from above, and then add in the 80 million that you generated in positive cash. Of course, you're estimating this. You're calculating this before it happens. So this is all based on estimated numbers, although the initial cash outflow might be a real number, or probably it's the most accurate estimate you have. Okay, and so then if I'm negative, that's 1 year of payback at least, and then you just repeat the process. So if I delete this now so you can see it, what you do is you keep doing this until you go positive. Okay, once we're positive, we really don't need to do this anymore. You could leave it or not. And here's what you do. You say, every year we're negative, that was a year of payback. And then when we look at period 5, we see that we go positive. So we've got to calculate a portion of a year. How do we do that? Show you what you do. You take the prior year amount you have yet to go, which is 23 million. Take the absolute value of that. So if it's 23 million is a negative number, if you subtract it, equal negative 6.8, that's equivalent to multiplying times a -1. And that turns it to a positive number, and then divide it by 70,000. Okay, that'll get you 0.33. Now, you could just use an absolute value function. And in Excel, that's ABS, absolute value. Then you would hit the left parenthesis. I come up here, call up that function, will look like that, and then you say, what's the number? Well, it's that number divided by that number. Okay, now we know a negative divided by a positive gets you a number, but because that's the absolute value function, it'll turn it to a positive number. So you could do it that way too. Now, once we've gone positive for the first time, we don't have to count any more payback periods, then just sum that. And that comes out to be 4.33 years. Okay, so that's payback in years. Okay, that's how I like to do payback. Now, by the way, if all these numbers were the same, let's just assume all of it was the same, our value would change, but you could calculate it easier. You could just simply take the absolute value of 350,000. So I'm going to take the absolute value, I'll call it up, 350,000, divide it by the annual amount, 80 million, and yeah, put this down here, all right? And you see it's the same number. Now, if I format that, it'll be exactly the same. Okay, so if all the numbers are the same, doing payback in years is a lot simpler. Now, I never use this approach because I think realistically, you probably can come up with some decent assumptions so that would show that on various projects all numbers wouldn't be the same. All right, let me just go back and leave the numbers as to what they were so you can see that demonstration. Okay, now I've adjusted the screen a little bit. Now I want to demonstrate internal rate of return using this exact same example. So these are the same cash flows here that we have here. Guess I could have just done this down here, but I'll demonstrate it off to the right. Internal rate of return just basically asks the question, what's the internal rate of return on this project? And it considers the time value of money. I'll explain what it means a little bit more when we cover net present value. But how you mechanically do it, Excel is the easiest way to do internal rate of return. Okay, you simply type in equal IRR, hit left parenthesis, and then give it the stream of values that occur at regularly scheduled times. Okay, so I'm going to now point to the values and you just give it the range. Now it wants to know a guess. I can tell you that for most financial situations, most financial examples, a guess doesn't matter. This has to do with local mins and local maxes, that's local minimums and local maximums, because in rare instances or some instances, internal rate of return can give you two different answers. So if you have an estimate of what that internal rate of return might be, you should put it in. Now, if you're given a problem with a net present value and say the net present value was 8%, I would put that in as the guess. But quite frankly, the answer won't change, at least for the kinds of problems we'll see, whether you include it or not. So I'm going to put in 8% and I get 14.15. Now, if I call that back up and remove it, you'll see that it's still 14.15. Okay, just something to keep in mind. I'm going to put that 8% in here. All right. Now, what is internal rate of return? Well, internal rate of return is that rate earned if we force net present value of these to be zero. So I'll return to that in a minute, and let's talk about net present value next. Okay, now I've adjusted the screen again so that we've covered payback, we've covered internal rate of return. Now let's look at net present value. Now, net present value can be solved a number of different ways. You can use the table approach, and lots of textbooks present table, right? Table information of the net present value of $1, net present value of a stream of cash flows, and I believe I have a video or two that illustrates that approach. But today I'm just going to illustrate net present value using Excel. You can also solve net present value and internal rate of return with calculators, online or physical ones. I personally find Excel to be the best because it leaves a great audit trail. And in this day and age, everyone has Excel or Google Sheets, and Google Sheets can do this as well, right? Or whatever Apple's equivalent of Excel product is. All right, so here we have the cash flows again. Again, the same scenario. Interest rate is 8%. That would be given. With net present value, they would give you a discount rate or an interest rate or a cost of capital rate. Okay, I'll leave it to a managerial finance class to explain what goes into the cost of capital and how you could calculate it. But for our purposes today, we're going to assume it's given to you. All right, so you can do this in one cell or a few cells. First, we have to calculate the present value of the cash flows. And the way you do that is you use the NPV function. So let me just start from scratch. In fact, I'm going to delete these. And we'll say equal NPV, left paren, call it up, insert function. Wants to know where the rate is. Let me put this on the screen so you can see it. Where's the rate? Well, the rate's given in that cell there. Okay, next it wants to know the values. Now, again, you could put these in one at a time, but read this. It's 1 to 254 payments in income, so it means it can be positive or negative cash flows, equally spaced in time and occurring at the end of each period. So you can't put in the first one. The first one occurs now. So the first one occurs right there, the end of period 1, and then you could either put them in value 1, value 2, or just slide and give it that array, and it has the information. So now let me hit OK. And what we've done is calculated the present value of the future cash flows. Okay, that's the present value of the future cash flows. Then you have to subtract out the immediate cash flow. So I'm going to just, since that's already as a negative, I'll add that in. And if we do that, take that cell, the present value of the future cash flows, minus, oh, I think I hit the equal by mistake, minus the immediate cash outlays, you come up with net present value. Okay, and that's the answer. I could double underline that if we wanted to see it. But you could also calculate it directly. Let me demonstrate how we would do that. Oh, the 779, that needs to be a plus, not a minus here. Okay, so the net present value is 79,582. Now, let's explain what that means. This means that if we take on this project or this course of action and we spend $350 million and we anticipate getting these kinds of cash flows for the next 8 years, it means that the wealth of the company is better off to the tune of 79,582,000. So keep in mind this is an estimate. So the company would be better off by taking this project on. Now what that means is if net present value is 0, that would be a project that you should reject based on the quantitative analysis. You still want to consider qualitative considerations. Sometimes it makes sense to take on a project that looks like it will lose money, but it's something you need to do, right? Maybe it's good for the community or good for your workers' health, or it improves the quality of the product or the image of the company. You know, lots of these has benefits that will benefit the company, but perhaps are impossible or extremely difficult to quantify. So you need to consider both quantitative and qualitative considerations. All right, so to do this directly, you would just say NPV, left paren, give it the rate. Oh, let me call it up again. Let me do it. Start again. Equal NPV, hit the left parenthesis, then come up here, hit the insert function button, and then point to what you need. Give it the rate. And now what you need is the NPV. So beginning in period 1 through the end. And you're not done. That's just the positive cash flows. And then you would have to add in by adding another component to this formula and add in the 350,000. So that's how you would do it with Excel in one cell. And you see here that the numbers are exactly the same. All right, so now internal rate of return, I want to go back and explain modified internal rate of return. Internal rate of return represents that rate. The internal rate is if net present value was equal to 0. Okay, it represents the rate we would use to force net present value to equal 0. Well, let's prove that. Let's make this that number and watch what happens to net present value. As soon as I do that, net present value becomes 0. Okay, so that's what internal rate of return does. It calculates the NPV and forces the rate so that NPV would be equal to 0. Now, I'm going to put this back. Now, what this also shows is as we increase the interest rate, if we go to the net present value will drop. Now it's 64.7 million. If I go to 10%, it goes to 50 million. You get the idea. All right. Now, once I pass the point where it's 0, like I'll make this 15%, you'll see NPV will go negative. All right. I'm going to put that back to 8%. So this internal rate of return has a major weakness. It assumes that all of these positive cash flows are reinvested at the internal rate of return rate. So it assumes when we get 80 million, we have other opportunities to invest an additional 14.15%. Quite honestly, that may not be realistic. I would argue that if you're using an interest rate of 8%, probably your next best alternatives are 8% or very close to it. So the modified internal rate of return adjusts for that. And the reason that this came into popularity, in my opinion, is because of this weakness. Managers love to evaluate courses of action in terms of percentages. That way they can compare one alternative that may be very large, a $350 million investment, to one that may be very small, 5 or 10 million. Could be any size investments, and figure out which one they want to pursue. Technically, that's the wrong approach to use. The best approach is always NPV, and if you're limited for capital, you want to choose the ones that have the highest chance of increasing the wealth of the corporation, which in turn increases the wealth of the shareholders. Okay, now, because of that weakness, and because it's likely that those future cash flows can only be invested at 8%, modified internal rate of return adjusts for that. So we type equal MIRR, hit left paren, call it up, put in the values. Now remember, with IRR, you can put in the initial negative amount. And then it says, well, what's the financing rate and investment rate? And if you're not given specific differences, or you don't know them, the cost of capital or the discount rate or the interest rate is what you should use. So we'll put in 8% for both. And now you'll see we come up with a different number that's much lower. And quite frankly, I think the modified internal rate of return is a much more realistic understanding of what this project returns. So that way, if someone were to say, well, what kind of interest rate, what kind of return are we going to get on this project? It's more likely you're going to get 10.8% than 14.15%. Okay, so this has been a walkthrough of payback, internal rate of return, net present value, and modified internal rate of return.